ओके सब आगे। कितने लोग, मतलब एक 5 मिनट बीच में होता है तो पेशाब पानी सब कितना निकल जाता है तुम्हारा। आ जाओ जल्दी, पीछे वाले आगे आ जाए, नहीं तो मैं खुद। हाँ बस आ जाओ। ये किसके लिए, एक जगह किसकी खाली है? अरे आओ ना भाई जल्दी। सी वी आर गोइंग टू स्टडी विद द बैरियर पोटेंशियल एंड टेम्परेचर नाउ। मैंने कहा था ये सब आगे का पढ़ के आ जाना। कितना पढ़ा है, कितने? हाँ हाँ। अरे तिगरिया, तुमने कहाँ तक पढ़ा है? 1.5 1.5 1.5 तक क्या? 1.5 पढ़ लिया है? 1.5 पढ़ लिया है। 1.5 बड़ा वाला पार्ट है। ओके 1.5 में क्या तुमने? 1.5 सब 1.5 is all about voltage ampere characteristic of a diode। मतलब 1.5 तक ना पढ़ाओ तो अब चलेगा ना। चलिए 1.3 से स्टार्ट करते हैं। The internal temperature of p-n junction is known as junction temperature, whereas that of air surrounding the device is called ambient temperature। देख लीजिए what is ambient temperature। टेम्परेचर ऑफ एयर सराउंडिंग है डिवाइस। ये मेरा लैपटॉप है, इसके आजू बाजू जो ये एयर है दैट इज एम्बिएंट टेम्परेचर। उधर जो टेम्परेचर, और जंक्शन पे जो होता है वो जंक्शन टेम्परेचर। फॉर कंडक्टिंग डायोड द जंक्शन टेम्परेचर इज ऑलवेज हायर देन एम्बिएंट टेम्परेचर। In doubt, nothing great to explain here. The barrier potential of junction is dependent on the junction temperature. The barrier potential decreases with the increase in the junction temperature. जैसे temperature बढ़ेगा barrier potential कम होगा। So they are inversely proportional. You can say that, लिख लीजिए कि the barrier potential decreases with the increase in the junction temperature. Due to increase in temperature, more electron hole pair are produced. As the temperature increase, so more number of electron and hole pairs will be produced. कौन है ये जो रोज मोबाइल मुझे बहुत तंग कर रहे हो तुम? आई एम रियली गेटिंग डिसअपॉइंटेड। लास्ट वार्निंग, सब अपने मोबाइल निकालो, साइलेंट करो। 5 minutes to you। जल्दी भाई, मेरा बजेगा तो भाई, मेरा तो बजना चाहिए ही, नो डाउट इन दैट। तुम होते कौन हो मुझे रोकने वाले? ओके, जोक्स अपार्ट। ड्यू टू इंक्रीज इन टेम्परेचर द मोर इलेक्ट्रॉन पेयर hole pair will be produced. This will diffuse into depletion region to narrow it down। तो उससे डिप्लीशन रीजन की विड्थ कम होती जाएगी क्योंकि वो सारे वहाँ डिफ्यूज हो जाएंगे। दिस नैरोइंग ऑफ डिप्लीशन रीजन रिजल्ट्स इन रिडक्शन ऑफ बैरियर पोटेंशियल। डिप्लीशन रीजन की विड्थ कम हुई तो व्हाट विल हैपन? द बैरियर पोटेंशियल विल डिक्रीज। द बैरियर पोटेंशियल ऑफ सिलिकॉन डायोड डिक्रीजेस एट 2 millivolt per degree Celsius। राइज इन जंक्शन टेम्परेचर, ये एग्जाम्पल दिया है कि 1 डिग्री टेम्परेचर बढ़ाओ तो 2 millivolt कम हो जाता है बैरियर पोटेंशियल ऑफ सिलिकॉन। इफ यू वांट दिस एग्जाम्पल, चलो छोड़ो, कुछ काम करो, लिखना है तो लिखो यार। एडवांस कॉन्सेप्ट अबाउट रिवर्स बायस डायोड। ये हमने बेसिक समझ लिया कि रिवर्स बायस क्या होता है, फॉरवर्ड रिवर्स कैसे कनेक्ट होता है, क्या रेजिस्टेंस होता है, क्या वोल्टेज होता है, ब्रेक डाउन के बारे में समझा थोड़ा बहुत क्या डीपली तो समझा है जेन और एवलांचे। वो मैंने टेबल बनवाया था ना, डिफ्रेंशिएट बिटवीन एवलांचे एंड जेनोर, वो ध्यान से याद रख लेना। Let us now discuss few advanced concepts related to the reverse bias diode. The width of depletion region changes with the change in the reverse voltage. Sorry, ये तो मैंने आपको समझाया। Width changes. तो ये 1.3 में हमने क्या बोला, टेम्परेचर और बैरियर पोटेंशियल, वो समझ गया ना सब, कि जैसे ही टेम्परेचर बढ़ेगा बैरियर पोटेंशियल विल डिक्रीज। दिस इज व्हाट इट इज ट्राइंग टू से। क्यों? मोर इलेक्ट्रॉन विल come out, more of them will fuse at the depletion region, the width decreases, the barrier potential decreases. We will now discuss the various effects related to reverse bias diode. ये लेज़र वहाँ पे नहीं डिस्प्ले होता ना, हाँ ऑफकोर्स स्क्रीन पे नहीं आएगा। नैरो से करूँ तो आपको क्लास में कौन सा इंटरेक्टिव लगेगा, एरो और लेज़र, ठीक है, मैं कॉम्बिनेशन ऑफ बोथ यूज करता हूँ। रिवर्स सैचुरेशन करंट एंड टेम्परेचर। द रिवर्स सैचुरेशन करंट डिपेंड ऑन द टेम्परेचर, एज आई हैव ऑलरेडी टोल्ड यू। इट डबल्स इट्स वैल्यू फॉर एवरी 10 डिग्री Celsius rise in temperature. This is just not true for everywhere. Hence, the constant temperature, the reverse saturation current remains constant, independent of the reverse voltage. No doubt in this. Temperature is constant, then there will be no change in the reverse current. This is what it's trying to say. Reverse current flow due to minority carriers which are produced due to elevated temperature. Hence, the reverse current is dependent on temperature. No sincere doubt in this. No sincere doubt. If you have, then please contact. Tell me please now. Yes. Say reverse current flow due to what? It's minority or majority carrier? It's minority carriers that due to which it's flow. So it's all dependent on temperature. Hence the reverse current is dependent on temperature. That's what it's trying to say. The dependence of I naught on temperature can be mathematically expressed as follow. Be it formula level. Go to low. I naught is equal to K. I naught is equal to KT. What is K? I have explained it here, everything. K is constant which is independent of temperature. M is equal to 2 for germanium 1 point. It's also a constant here. Forbidden gap germanium सिलिकॉन का दिया है, लिखो सारे के सारे। Practically we need not always use the expression for I naught to calculate the reverse saturation current at the new temperature. As we know that there is 7% rise in I naught for every 1 degree temperature rise, we can express this mathematically as, देखो वो बड़ा फॉर्मूला याद रखना कठिन है, पर आपको सही कैलकुलेशन चाहिए तो वही लगाना पड़ता है। पर ऐसे मामू लोग हम जैसे क्या करते हैं, अंदाज़त पता है कि 1 डिग्री टेम्परेचर बढ़ा है 1 डिग्री सेल्सियस तो 7% राइज होगा, तो ऐसा अपना मामू फॉर्मूला है। क्या ये मामू फॉर्मूला कि आई नॉट इज इक्वल टू 1.07, पता चला ये कैसे 7 डिग्री राइज, एंड दैट इज डेट टी I naught 2. I naught 1 is reverse saturation current at temperature T1 and that is reverse saturation current at temperature T2. कोई भी दो चीज़ दी हो तीसरी पता चल जाएगी। नन्नी मुन्नी जापानी गुड़िया जैसी तू, हुआ ना मनोरंजन, चलो पढ़ाई शुरू। Some important conclusion related to reverse saturation current are as follows. ये conclusion लिख लो. Reverse saturation current increase at the rate of 7% for every 1 degree Celsius rise in temperature. In other words, I naught doubles itself for every 10 degree Celsius rise in temperature. This is what we approximately uses. The reverse saturation current for silicon diode is lower than that of germanium diode at same temperature. Silicon का reverse saturation current is lower than germanium. Please write down these 2 points while I have a sip of water. Now we will be studying about silicon versus germanium. Very interesting topic to study. Please, I would request again the students at the back to maintain discipline in the class. Silicon versus germanium. The reverse saturation current of the... Yes, what's happening there at the back? Yes. Any doubt? Then why discussion is going on there? I don't want any noise from there. If you want, you can leave this class and do not hope for your attendance anymore. Yes, I want that you remember this, that 2 guys on the left corner and one in the middle. Yes, you 3 will not get attendance today. I'm really sorry for that. Silicon versus germanium. Silicon saturation current. The reverse saturation current for germanium diode is 3 to 4 times higher than silicon diode for the same dimension and doping densities. अगर बाकी सब चीज़ें सेम रखें ना तो जर्मेनियम का 3 से 4 टाइम्स करंट हायर रहता है as compared to silicon. Suppose we in voltage is 0.2 voltage for germanium diode, and then it's 0.6 for the silicon diode, for the current to be same in them. I don't think there's such an important topic to discuss any more about this. You can write down this. It's much more higher in germanium for the same dimension and the doping densities as compared to silicon. The current is higher. Why does this germanium diode produce higher reverse saturation current? ऐसा क्या है जो जर्मेनियम में ज़्यादा? क्या है ऐसा जर्मेनियम में जो हमारे सिलिकॉन बबुआ में नहीं है ना? चला पता लगाते हैं कि सिलिकॉन बबुआ में ऐसा क्या नहीं है और जर्मेनियम बबुआ में ऐसा क्या है. The 4 valence electron of germanium are in the 4th shell, whereas for those in silicon are in the 3rd shell. Valence electron silicon के जो है वो 3rd shell में, germanium के 4th shell. Therefore, the force of attraction between the nucleus and valence electron is weak in germanium. तो क्या हुआ? न्यूक्लियस का फोर्स इलेक्ट्रॉन्स पे कम है in germanium as that compared to silicon. forbidden energy gap is smaller in GE than SI. जर्मेनियम में एनर्जी गैप, आपको मैंने पढ़ाया था ना कि कंडक्शन बैंड, वैलेंस बैंड, बीच में जो एनर्जी गैप होती है दैट इज फॉरबिडन एनर्जी गैप, इन फिजिक्स यू हैव स्टडीड दैट इज हायर in silicon and smaller in germanium. Therefore, GE diode, germanium diode, at given temperature, more valence electron will jump. In germanium diode, more valence electron will jump to the conduction band and produce higher reverse saturation current as compared to silicon. समझ गए बबुआ जर्मेनियम का फायदा कि जर्मेनियम में फॉरबिडन एनर्जी गैप कम है तो ज़्यादा इलेक्ट्रॉन कूदेंगे कंडक्शन में वैलेंस से और ज़्यादा एनर्जी, ज़्यादा करंट, ज़्यादा। बट तो भी बबुआ, वाई सिलिकॉन डायोड इज मोर पॉपुलर देन जर्मेनियम डायोड? सी करंट, दो करंट इन रिवर्स करंट इज मोर इन जर्मेनियम, वाई स्टिल सिलिकॉन इज मोर पॉपुलर? The reverse saturation current for silicon diode is much lower than germanium diode. Therefore, even with a two-fold increase in I naught every 10-degree rise in temperature, the reverse saturation current through silicon diode will still remain very low. Temperature चाहे आप बढ़ाओ, जितना भी बढ़ाओ, आप बढ़ाते जाओ टेम्परेचर, उसमें तो जर्मेनियम में करंट ज़्यादा थी तो अब डबल हो जाएगी और डबल होगी, कितनी बढ़ जाएगी? बस सिलिकॉन में तो ऑलरेडी कम है, अब बहुत बढ़ाओगे तो भी ज़्यादा करंट बढ़ने नहीं वाली टेम्परेचर बढ़ने से। बट इंक्रीज इन टेम्परेचर द रिवर्स सैचुरेशन करंट थ्रू अ जर्मेनियम डायोड इज़ वेरी हाई ऑफ द ऑर्डर नियरली 100 microampere or so. This level of reverse saturation current is incompatible in practice. Therefore, silicon are more popular. तो करंट बहुत ज़्यादा बढ़ जाएगी और इतनी ज़्यादा करंट इज़ इनएक्सेप्टेबल, हम एक्सेप्ट नहीं कर सकते ये करंट रियल लाइफ में। आपके लैपटॉप्स में सिलिकॉन यूज़ होता है, पता है? That is why we use silicon. Ideally, the diode characteristics should not change due to change in temperature, and practically the change in characteristics should be small as possible. The characteristics of germanium diode are more dependent on temperature than silicon diode. एक मिनट, आप में से कोई एक इधर आओ, ये मेरा लैपटॉप का ये वाला पोर्शन टच करो, कितना गर्म, कैन यू फील इट? ओ माई गॉड, मेरे तो हाथ, अब इतना भी गर्म नहीं है, बट देर इज़ अ क्वाइट हायर टेम्परेचर, आप फील कर पा रहे हो कितनी गर्मी है। नीचे वाला पोर्शन टच करके देखो, हाँ देखो, ये पंखा चालू है, मतलब समझ लो ये तो पंखा अंदर कितनी गर्मी होगी, ये फील कर पा रहे हैं आप ये गर्मी। इतना हाई टेम्परेचर है, टेम्परेचर के साथ अगर कैरेक्टरिस्टिक्स बदलेगा तो कैसे चलेगा? जर्मेनियम बदल देता है, while silicon does not. So we prefer silicon. 1.5 यहाँ तक पढ़ा है ना आपने? 1.5 पूछूंगा अभी मैं। अरे कौन था वो जो पढ़ के आए थे 1.5 तक? सारे हाथ ऊंचा करो। देखो एक गेम खिलाता हूँ, टू 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 टू। voltage ampere characteristic of a diode, that is 1.5, and this is a quite longer portion of our chapter. voltage ampere characteristic यानी वो डायग्राम, ये ग्राफ कैसा बनता है? पढ़ लेते हैं इसमें क्या क्या टॉपिक है. सबसे पहले we will study forward characteristics of p-n junction diode, then we will study reverse characteristic of p-n junction diode, complete VI characteristic of a diode, complete VI characteristic of silicon and germanium diode. कंपेयर करें जाएंगे, कंपैरिजन टेबल होगा. bulk resistance, this is a quite long topic I think. mathematical expression for the diode, एक चैप्टर में नहीं हो पाएगा, मतलब एक क्लास में नहीं हो पाएगा, सॉरी मुझे नहीं लगता हो पाएगा आज का. आज मेरी 2 क्लास है ना, बोर होने वाले. आज रेडी हो जाना. इफेक्ट ऑफ टेम्परेचर ऑन वी आई कैरेक्टरिस्टिक. उसके बाद 1.6 में क्या आइडियल डायोड. कितना बाकी है ये चैप्टर. सेकेंड अप्रोक्सीमेशन, थर्ड अप्रोक्सीमेशन, देन वी हैव कंपैरिजन. न्यूमेरिकल्स मेन है, मैं वो करवाना चाहता हूँ पहले. रीडिंग डेटा शीट भी आना चाहिए. मैं डेटा शीट लेके आऊँगा इस वक्त, जब ये वाला पार्ट पढ़ा था. सरफेस माउंट डायोड, देन वी फिनिश दिस चैप्टर एप्लीकेशन के साथ. क्वाइट लॉन्ग चैप्टर, पर मज़ा बहुत आएगा. तुम लोग देखते जाओ. मुझे तुम्हें तो पता नहीं कब आया है मज़ा. जीवन में तुम लोग को कभी मज़ा आया अभी? और जूम करूँ, फट जाएगी शायद इमेज. Clearly visible till the last bench now. The voltage ampere characteristic of a diode. The behavior of p-n junction diode is indicated by the volt ampere characteristic. कितना टाइम है? अरे अभी तो बहुत टाइम है. देखो, the VI characteristic of a p-n junction diode is a graph of voltage across the diode versus the current flowing through it. वोल्टेज और करंट के बीच में जो ग्राफ बनाएंगे, दैट इज कॉल्ड VI कैरेक्टरिस्टिक ऑफ अ p-n junction diode. The VI characteristic can be divided into 2 parts, forward and reverse characteristic. We will study one by one both. First we will study about forward characteristic of a p-n junction diode. These were some important questions that were asked from this particular topic. It was once asked in 2010 for 2 marks and 2013 for 4 marks. What is a cut-in voltage? ये आप समझ जाओगे. What is approximate value of cut-in voltage for silicon and germanium? ये रटने की बात थी. What is draw diode VI characteristic? क्वेश्चन लिख लो, क्वेश्चन लिख लो, क्वेश्चन लिख लो, क्वेश्चन लिख लो, क्वेश्चन लिख लो. नहीं लिख रहे, वो बहुत पछताएंगे, बहुत पछताएंगे. द फॉरवर्ड कैरेक्टरिस्टिक, यार लिखो. ओके मैं पढ़ा रहा हूँ, यू लिखते जाओ, लिखते जाओ, लिखते जाओ, लिखते जाओ. द फॉरवर्ड कैरेक्टरिस्टिक ऑफ अ ग्राफ ऑफ अ एनोड टू कैथोड forward voltage VF versus the forward current Yes, 1 minute. You all read this till I am coming. चालने का है. Sorry, there was some important work. Read this one, please. I want every one of you to silent your mobile phones. Only my mobile phone can ring in this class. The forward characteristic is divided into two portions, AB and BC, as shown in figure 1.5.1a, and the corresponding circuit 1.5.1b. We will read this characteristic, that is VF, forward voltage versus current in the forward bias, forward current, reason by reason. First, let's see the diagram. I want you all to draw this diagram that I am showing you now. First of all, you draw this graph. Quick. I am not playing game in my mobile. All those who are looking at me like, what? कॉलेज का ही काम कर रहा हूँ कुछ. Okay, I hope you all have drawn the graph. Now look at the graph and what I'm reading, listen to that. In the region A to B of the forward characteristics shown in figure 1.5.1a, the forward voltage is small and less than cutoff voltage. Therefore, the forward current flowing in through the diode is small. From region A to B, the current is quite low, as you can see. As the cut-in voltage, we have less amount of voltage supplied in the circuit as compared to the cut-in voltage. What is cut-in voltage? We will be reading it, studying it, learning it in the further classes. With a further increase in the forward voltage, it reaches a level of cut-in voltage and the width of depletion region goes on increasing, as you can see in the graph. I want you all to draw this diagram. Till then, I will be reading through the B to C. You just listen and draw at the same time. As soon as the forward voltage increase, the cut-in voltage current through the diode increase suddenly. The nature of this current is exponential. The large forward current in the region BC of the forward characteristic is limited to connecting a resistor R in the series with the diode. Forward current is of the order of few milliamperes. The forward current is a conventional current that flows from anode to cathode. Therefore, it is considered to be positive current, and forward characteristic appear in the first quadrant as shown in figure 1.5.1a. There is sudden increase in current after B. You see, after the current crosses cut-in voltage, there is sudden increase, and this is what is the VI characteristics in the forward bias, but there is not that great sudden increase that we will see in the reverse bias. All of you now write down the voltage, cut-in voltage definition. It's also called knee voltage. कुछ चुल्लू भर लोग चुल्लू भर कह रहा हूँ मैं, they call it knee voltage. अब आपके एग्जाम में चुल्लू भर में से आया तो मुझे नहीं पता, लिख लीजिए. The voltage at which forward diode current starts increasing rapidly is known as cut-in voltage of diode. This is the definition. It's very close to barrier potential, maybe not exactly equal to it every time. Cut-in voltage is denoted by V. You can write this. VR. Cut-in voltage is also called knee voltage, जिसे मैंने कहा चुल्लू भर लोग बुलाता है knee voltage. Generally, the diode is forward bias above the cut-in voltage. The cut-in voltage of silicon is 0.6 and it's 0.2 for germanium. लाख बार लिखवा चुका हूँ, शायद मैं बुलवा चुका हूँ, पढ़वा चुका हूँ, याद रह जाना चाहिए. 0.6 for silicon, 0.2 for जर्मेनियम. यही दो चीज़ों की तो बात की है हमने. आज दिल शायराना 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 लगता है. रिवर्स कैरेक्टरिस्टिक ऑफ अ डायोड. You may write down this question. Draw the VI characteristic. It was asked in 2013 May for 4 marks. The reverse characteristics of a graph of reverse voltage versus the reverse current is shown in figure. You must draw this, both the figures. I'm giving you some quite a little bit of time. At the same time you are drawing, listen to me with your ears. Current flowing through the diode in the reverse bias state is the reverse saturation current, which flows due to minority carriers. I guess you are not able to understand this. I know you will not be able to. I have already taught you this. The reverse current is due to minority carriers. I hope you have drawn this, and if you have not drawn, that's your mistake. Please copy it from your neighbors, friends, family, if there is someone from your family here sitting in the class. Therefore, it is treated as negative current. Hence, the reverse characteristic appear in the third quadrant as shown in the figure. As the reverse voltage is increased, the reverse saturation current remains constant, equal to IF I naught. See, temperature is not changing. So the current here is almost. I'm just fed up with this type of computer system. The current here is totally constant as temperature is not changing. This is because reverse saturation current does not depend on the reverse voltage, it depends on temperature, as I have explained you. But the reverse voltage reaches the breakdown voltage at the large amount of current will flow through it. Due to the reason discussed earlier, we have discussed two reasons, avalanche and Zener breakdown. Thus, we define the reverse breakdown voltage for a PN junction diode as a reverse voltage at which breakdown takes place and large reverse current starts flowing through the diode. Operating in the reverse region should be avoided because diode may get damage due to excessive power. Typically, the reverse voltage of PN junction diode is in the range of 50 to 100 volt. See, I have explained you this all things. Still again explain you through the graph. Basic graph. Okay, I'm not using laser now, so that you can see in the video clip also. Here there is a sudden increase and you may reach at the particular voltage, particular point where fixed current is of I naught is produced. And even though if you are increasing the reverse voltage, there is no change in this because the temperature is constant. But at the point of breakdown, there may be avalanche or Zener. There is sudden breakdown and therefore there is sudden increase in the temperature. The sudden increase in the current. But you must avoid this. Reasons are explained earlier. उड़ता हुआ दिल संभलना जाने ना आज दिल शायराना शायराना शायराना. Draw this graph. I am waiting for you. Write these questions and draw this graph. उड़ता हुआ दिल संभलना जाने ना आज दिल शायराना 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 लगता है. अरे ये सब भी तो रिकॉर्ड हो रहा है. नो प्रॉब्लम, एंजॉय. हाँ हाँ भाई. It is obtained by combining the forward and the reverse characteristic of a diode. Explain. Yes, you explain. क्या बोला ये अंग्रेजी? तो VBR means breakdown voltage is the reverse voltage breakdown. यही मैंने कहा. Is the reverse voltage at which the breakdown occurs. Nothing great to explain. The reverse voltage I naught up to VBR is practically constant. And negligibly small. बहुत slowly जा रहा हूँ मैं, just because you people can understand. So we can neglect it at a low operating temperature. I hope you understood the graph. Forward, reverse. We have come first. We learned about forward. Then we learned about reverse. Then we combine both. TM Cook fans control. complete VI characteristic of silicon and germanium diodes. What you can see is the combination of both in the graph. VI characteristic of combination of forward and typical VI characteristic of silicon and germanium are shown in the figure. What you draw this both. 1, 2, 3, 4, 5. Cut-in voltage for silicon and germanium diode are 0.6 and 0.2 voltage. ये बहुत बार बोल चुका हूँ मैं, थक चुका हूँ ये बोल के. As you can see here, it is 0.2, 0.6 cut-in voltage. फॉरवर्ड में आता है कटिंग वोल्टेज, रिवर्स में क्या आता है ब्रेक डाउन वोल्टेज. ब्रेक डाउन वोल्टेज फॉर सिलिकॉन इज हायर देन जर्मेनियम, सो सिलिकॉन डायोड कैन बी विथस्टैंड एट हायर रिवर्स वोल्टेज. इसमें कुछ एक्सप्लेन करने लायक है. द रिवर्स सैचुरेशन आई नॉट फॉर जर्मेनियम डायोड is few new ampere, whereas that for silicon diode is nano ampere at room temperature. Think great to explain, already told you all this. ग्राफ देख के सब समझ रहे हो. एनी डाउट इन द ग्राफ? ध्यान से देखो, ध्यान से देखो, ध्यान से देखो. अभी भी कुछ लोग बना रहे हैं आजू बाजू से देख के. भाई इधर देख के बनाओ. Let's compare this. टेबल ये क्वेश्चन आता ही है, मतलब आया गया है तो समझ लो. Silicon diode, germanium diode. We will be comparing the both based on the material used. Of course, as the name suggests, silicon is used in silicon diode, germanium is used in germanium diode. Cutting voltage is 0.6 for the silicon diode. I have told it earlier also, 0.2 for the germanium. Reverse saturation current is in nanoamperes and it's in microamperes. तो किस में ज़्यादा है? It's germanium में ज़्यादा है. नीचे कैम स्कैनर देख के इतनी क्या हंसी खुशी है आपको. Effect of temperature is very less. Less effect of temperature is seen in silicon and more is seen in germanium. Breakdown voltage is higher for silicon, so it can withdraw more amount of voltage, and lower in germanium. Application of rectifier. We will be learning all this in the next chapter. What is a rectifier, clipper camper, freewheeling, low voltage, low temperature application are there in germanium. I am feeling bored teaching you now, so I think we should stop here. No, I cannot stop until the bell rings. कितना ये 5 ख़त्म ही कर देते 1.5. मुझे लगा था नहीं होगा पर हो जाएगा. अरे आदमी चाहे तो क्या नहीं कर सकता. Bulk resistance is defined. Define bulk resistance, barrier potential. Barrier potential we have already defined. Now we will be defining bulk resistance. As said in the VI characteristic of a diode, above the knee voltage, the diode current increases rapidly. That means a small increase in diode voltage will result in a large increase in diode current. I think we are able to understand. Write down this definition. Once the barrier potential is overcome, the only possible resistance offered by the diode to the flow of current is the ohmic resistance. Ohmic is normal resistance that we all usually have in any simple circuit, offered by the P and region. The sum of ohmic resistance of P and N region is called bulk resistance. This is the definition. Mathematically, BR is equal to BP plus B, and BP is the ohmic resistance of P region and N region का होता है ohmic resistance से कहता है. R and the bulk resistance developed depend on the bulk resistance depend on the size of the P and N and the doping level. Xenon में doping ज़्यादा तो resistance may be. Typically bulk resistance is less than 1 ohm. ना के बराबर जी, ना के बराबर. लिखते जाओ. I am not wasting my more time here. Mathematical expression for the diode theory. Diode current. YouTube पे भी रख दूंगा इसे. वहाँ के आप इसको स्पीड करके देख सकते हो. 2x 1x 1.5 1.75 1.25. अरे जो मजा आए. और वहाँ के व्यूज़ से भी समझ जाऊँगा ना. ये 100 कितने 120 की क्लास में से कितने बंदे जाके देख रहे देखता हूँ. The diode current ID has exponential shape, mathematically expressed as ID is equal to I naught E V by nu V T minus. This is the mathematical expression of diode current. Write down the formula. I naught is the reverse saturation current. Diode current is ID. Vt is T by 11600 and is called voltage equivalent of temperature. Nu is 1 for germanium, 2 for silicon. Temperature in degree Kelvin is T. Voltage across diode. Constant nu is in equation is called emission coefficient or ideality factor. As mentioned earlier, its value is 1 for germanium and 2 for silicon. Voltage equivalent of temperature Vt. The voltage equivalent Vt of a given temperature T degree Kelvin is given by Vt is equal to kT volts. K is Boltzmann constant. T is temperature in Kelvin. लिखते जाओ. We are studying about Vt now. Vt is Vt. Write down all this. If you want the Xerox of this, it's available at our stationery. And if you want to buy it new copy or the old used copy, it's also available Write down all this. Thus voltage equivalent of temperature is dependent on temperature, and its pressure in equation of diode current is dependent on temperature. You must remember all this. Nothing great to explain here. Write down all this. Expression for the forward current IF. Expression of the reverse current IS. You must also remember IS is minus I naught. The expression shows that the reverse current IS is negative and constant, equal to I naught. Now the final part of this 1.5 part. There is one more. Mic. Where's my mic? Okay. Effect of temperature on VI characteristics. Expression of diode current is ID is equal to I naught E V by nu VR minus 1. We know that. What is V, T, what is nu, that's all written here. All the symbols. The diode characteristic is mathematically expressed by equation of ID. Two parameters I naught and VT is expressed for the diode current are temperature dependent, hence characteristic is independent of temperature. I naught and VT. What is I naught? Reverse current. What is VT? T by 11600. I think my mic has stopped working or what? You are not able to hear me. Hello. Okay. Hence the characteristic is dependent on the temperature. The effect of change of temperature in the VI characteristic is shown in figure. So this is what is observation. Let me read for you. Then you draw the diagram, please. Reduction in the cut-in voltage take place with the increase in temperature. As we increase temperature, as the temperature is increased, cut-in voltage decreases. Therefore, the same forward voltage, a larger current flows with increase in temperature. If you increase the temperature, the cut-in voltage decreases. That's obvious. The breakdown increases. The breakdown voltage increases with increase in temperature. Can someone explain this? I am waiting. Okay, I will give you a chance. Reverse saturation current increase with the increase in temperature. In fact, it doubles with the 10-degree rise in temperature. I have explained this earlier also. In the expression for the diode current, there are two factors which depend on temperature. That is I naught and VT. Hence the diode characteristic become function of temperature. Why does the breakdown voltage increases with the increase in temperature? You have more amount of minority carriers there. So the conventional current needed to oppose that minority carrier current. will increase. So what we learn from this graph, if you increase temperature, cut-in voltage decreases, breakdown voltage increases, and the current, reverse current, increases or itself doubles itself in every with every rise in 10 degrees Celsius. Okay, I hope you all have got this. Now I'm taking attendance. You three are not getting it. I want every one of you to read the further topics in this chapter and come prepared for the next class.